Here I'm going to redo the experiment of the shadow. This time the light source is a laser 532 nanometer wavelength and the same disk and rectangular plate and the same position. Here I have again camera with macro lens, and on the other side I will have observation screen, but we need a dark room because now we can't see anything here. Okay, now turned off the light and you can see slightly something. If you focus more, you may find something. But now, this is not what we are going to see. We are going to take a photo in long exposure, probably 15, 20, and 25 seconds to see what do we get. Here I set up the camera for 15 seconds. And now we are going to see what is the result of the photo. So now this is the result, and as you see, the circular plate that it was closer, nearer to the observation screen, stretches out, and the rectangular plate stretches inward, squeeze inward. The same result as what we saw with the shadows, and while the source light was sunlight. And now our light source is a laser with 532 nanometer wavelength. And as you see how the plate moves inward and the other one, the circular plate, stretches out. Let's continue back to what we had before. This was when the rectangular plate was nearer to the observation screen that, as you see, stretches outward. So, but this is not all. Now I'm going to add more information about it, which I think that one is much more fascinating. Assume a single slit and a laser as a light source, and the scenario of the diffraction. Everyone knows about it, and everyone knows about the diffraction pattern. I'm not going to explain things that everyone knows. But the question here, if I shift the laser to the right or to the left, as far as almost zero lux light passes through the slit, then what will happen to the diffraction pattern? This is what I'm going to explain now. To do this experiment, you need absolutely dark room because the light passing through the slits are almost zero lux. So the room must be perfectly dark. And then the exposure time of the camera and photography cannot be less than 10 minutes. So this is not something here I can show you on video. I can only show you the result. The result as this. The red doesn't matter how much light passes through the slit, the diffraction pattern still is symmetry, and you see the fringes, light bands in both sides. But for the green is a bit different. It's not symmetry. The number of light bands on the right, and I have to say that the laser was shifted to the right. So you see the number of fringes light bands on the right side is more than the left. However, the first left, it is much more brighter than the bright fringes on the right side. For the blue, this is more. So the number of light bands on the right is more, and the number of, and again the bright band on the left, it is much more brighter than the other. And as you may see that this is the slit, and the central band, the zero or the light band, shifted to the right. The same for the green, but for the red, this is less. So means that exactly the same as the refraction and the prism. Let's see a prism. So as you yourself know, the bending of the blue light is more than the red. And this is what exactly we saw on the previous image. For the red, we don't have that much bending. For the green, we have a bit. For the blue, we have the maximum. So again, we see that diffraction and the things causes diffraction related to refractive index. Thank you so much for watching this video, and I hope you enjoyed it.